When acyl chlorides react with ammonia, they do so by a mechanism called nucleophilic addition-elimination reactions. Let's start with our acyl chloride. In this particular case, we're using ethanol chloride, 2 carbons and then the acyl chloride functional group. The carbon is delta positive because of the electron withdrawing groups of oxygen and chlorine. Position your ammonia with its 3 hydrogens, so that the lone pair of electrons can attack the delta plus of the carbon. This releases electrons from the double bond onto the oxygen, the second bond of the double bond being the weaker bond. We'll start redrawing. The CH3 is unchanged. C single bond oxygen. The oxygen gains a negative charge and the lone pair of electrons are shown on the oxygen. The Cl is unchanged. The nitrogen is now bonded. Because it's used its lone pair of electrons to form the bond, the nitrogen gets a positive charge. At this point, this is the intermediate, and it's really important that that structure is correct. The O- with a pair of electrons and the nitrogen with a positive charge. A second ammonia arrives and acts as a base, using its lone pair of electrons to bond to the H+ that is released when electrons move from the NH bond onto the N that is positive. The electrons on the O- go back into the double bond, form the double bond, and the C-Cl bond is broken. We can now write out the products of the reaction. So, CH3, C double bond O, because the double bond has been reformed, NH2, we've got NH4 plus, the ammonium ion, and we've got Cl minus. We can now write the overall equation for the reaction in which the ethanol chloride, CH3COCl, reacts with ammonia, forming CH3CONH2 and ammonium chloride, which means that we need 2 lots of ammonia. The first lot of ammonia undergoes the nucleophilic addition reaction. The second lot of ammonia pulls off the H+ in the elimination reaction. The product of this reaction has a structure shown here, which can be identified as an amide. We've got to find that special C double bond O to recognise it comes from an acid, and we've got an amine group here, so it's an acid amide. In particular, this acid amide is called ethan amide.